డబుల్ స్పాన్ చాక్ పీస్లు మంచిగా ఉంటుంది. ఇది కోర్స్
సింగిల్ స్టార్
కోర్స్ కంపెనీ అది. ఒక నారాయణలో అంతా అదే అదే డబుల్ స్పాన్ అయితే మొత్తం క్లీన్.
డస్ట్ ఎక్కువ రాదు.
మధ్య లెసన్ మర్చిపోతున్నా, మధ్య లెసన్ మర్చిపోట్లేదు. పోయిన అదే ఎమోషన్ స్టార్ట్ చేద్దామంటే అంటారు. సిగ్నల్ లైన్ स्पीकर इधर से साउंड बाहर नहीं आते.
बाहर नहीं, एम्पलीफायर से कनेक्शन दे, एम्पलीफायर से इधर आता है.
हमारे पास भी नहीं
नहीं
आते.
आता है.
ये सिग्नल प्रॉब्लम. हाँ, सिग्नल में कर रहा है. ये बायो शांत हुए, बायो शांत हुए. कब भाई
फर्स्ट 6 days में रहता है.
हाँ कब टाइमिंग
फर्स्ट में रहता है.
टाइमिंग
वैसे 9 to 9:50 मैं BSN नहीं ना, इसलिए इनको
हाँ 9 to 9:50 मेरा है.
देखो क्या आज मंडे से बड़ा था इसलिए से.
हाँ वो मंडे ट्रेन से चेंज करे. हाँ Om Sri Guru Basavalinkaya Namaha. Dear students, welcome to our online classes. Today I want to introduce the new chapter, which is said to be current electricity. Current electricity. Already you know about the electric charge. Here, what is meant by electric charge? Electric charge means what? Electric charge means the excess or deficiency of electrons in a body is said to be what is called electric charge. Here, suppose let us assume that this is one body. Initially, in any body, the number of protons and number of electrons are equal. That means already we know the proton has positive charge and electron is having negative charge. Electron is having negative charge. So number of protons and number of electrons are It means what? The total positive charge equal to the total negative charge, the net charge will become 0. Suppose from this body if some electrons are lost by the body, then automatically here the net electron charge will be less and the proton charge as it is, that's why the charge is said to be positive charge. That means the body is positive charge by using what is that one? Its corresponding electrons. Suppose if anybody is losing the electrons, then we are able to say that its mass is said to be slightly decreased. Its mass is said to be slightly decreased. Why? Already we know electrons are having same mass. That's why when they lost the electrons, then the total mass of the body is slightly decreased. Similarly, suppose let us assume that this is another body, and suppose some electrons are gained by the body. That means what? Here the body net electrons negative charge will become more. That's why this body is said to be negative charged body. This body is said to be negative charged body. When any body is getting the negative charge, then automatically we are able to say that here the body mass is said to be slightly increases. Its mass is said to be slightly increases. This is about the electric charge. Here, suppose in any one body, if the electric charge is at rest, that means what? Here, if the electric charge is continuously occupying the same location with respect to time, then the study about this charge is said to be electrostatics. That is said to be electrostatics. Suppose if the electric charge is in motion, then the study about electric charge is said to be current electricity. Is said to be, what is that one? Current electricity. So current electricity means what? If any electric charge, that may be either positive or maybe either negative, if that is in motion with respect to time, then study about those charges is said to be current electricity. Here, before going to current electricity, first of all, we should know about some basic phenomena which are related with the current electricity. So, in the current electricity, first of all, you should know what is that one regarding electric current. Regarding this one, electric current. What is meant by electric current? Here already we know what is if electric charges are considered. If the electric charges are considered, if that electric charge, suppose let us assume that plus Q is the positive electric charge. If the electric charge is kept at a certain position, then we know that electric charge is at rest. Then the study about that electric charge is electrostatics. Suppose if this electric charge is kept in an electric field, like this, then automatically the electric charge is experienced by a certain force due to electric field. That electrostatic force in our previous chapter, F bar is equal to what? Into E bar. That means what? Here, if the electric charge is kept in an electric field, if the electric charge is positive, then the force is, electrostatic force, is acting on the charge in the same direction of the electric field. So, here some force is acting, that means what? This charge comes into motion. If this electric charge is coming into motion, then the charge per unit time is said to be electric current. Electric current means what? Here, if the electric charge is kept in an electric field, then the flow of charge per unit time is said to be electric current, is equal Q by T. This electric current is said to be, that is a scalar quantity. That is what is that one? Scalar quantity. That means what? Here for the electric current, it does not obey the laws of vectorization. That means what? Here when the electric current is adding at a point or dividing at a point, then it not depends upon the angle obtained in between the components. So let us assume that this is one nodal point. Nodal point means what? At any point if two or three components are joined at a certain point, then the point is said to be nodal point. Let us assume that O is one point, and from A to O, one conductor is there, from O to D, another conductor is there, and from O to C, another conductor is there. Let us assume that from point A to O, along this wire, suppose 10 ampere current is flowing. Then at the junction O, at the node O, it is having two paths. One is along OB and another one along OC. So let us assume that by depending on the nature of the wire, here 4 ampere current is flowing, here 3 ampere current is flowing. That means what? At node O, the 7 ampere current is into. Suppose let us assume that the angle subtended in between OB and OC was 60 degree. Suppose if this 60 degree is d to 45 degree, then also there is no change in current values. Suppose this angle is increased to 90 degree, then also there is no change in current values. That means what? Here it obeys, it accepts only ordinary radiation, but it does not accept the vectorization. So the electric is said to be scalar quantity. Another one, here, what is that one? Already we know the motion of the depending upon many factors. That is what? If the factor changing, then automatically the charge moving at a particular point is also continuously varies. At that time, instead of electric current, we should use real world that is said to be instantaneous current. That is said to be instantaneous current. That is denoted by small I. What is meant by instantaneous current? Instantaneous means what? If the current is continuously varying with respect to different factors, then that current is said to be instantaneous current. Only in mathematics we use this, we express this instant current in terms of differentiation. That means the rate of flow of charge. That means that is given by I is equal dq by dt. I is equal dq by dt. The next one, with respect to the magnitude and with respect to the direction, if the currents are considered, that is with respect to magnitude and with respect to direction, the electric current is classified into three types. Electric current is classified into three types. What are those? The first one is said to be steady current, and the second one is said to be varying current. The second one is said to be varying current, and the third one is said to be alternating current. Here the currents are classified into three types with respect to their corresponding magnitudes and direction. First one is said to be steady current, the second one is said to be varying current, and the third one is said to be alternating current. Here in its name only is there steady current. Steady means what? Constant. That means here you plot a graph in between time and current value. If the current magnitude and direction remain constant, if the current magnitude and direction remains constant with respect to time, that means as it is going on, then also there is no change in both magnitude and direction, then that is said to be steady current. That current is said to be steady current. Here varying current means what? Here suppose if you plot a graph in between current and time, if as time is going up, the current value changes. That means initially the current has more variation in magnitude, afterwards the current variation is with respect to time. That means initially if you see this particular time interval, the current variation changes from here to here. But after that same time interval if you see, the variation is little bit. After that same time interval if we almost the current is constant. So these types of currents are said to be varying currents. Another is said to be alternating currents. Here, if you see alternating current, in its name only alternating is there. Alternating means what? If any quantity continuously changes in a particular manner, that means that it may be depend upon any other factor, then that is said to be alternating current. So, if you see about this alternating current, here in the alternating current, if you plot a graph in between current and time, suppose let us assume that this is the time and this is origin and this is the positive current and this is the negative current. Suppose if you choose this is the time period t, then the midpoint represents half of the time period and quarter point represents t by 4, 1/4 of the time period, and 3/4 represents t by 4. Here, if you plot a graph from 0, that means initial point to up to the time period u, the variation is like this. And from t by 2 to t, the current variation is this. That means what? Here, the magnitude continuously changes. That means initially magnitude is 0, at t by 4 magnitude maximum, at t by 2 magnitude again 0, and at 3 by 4 maximum, and at t also again 0. Like that it's changing. Direction if you see, R1 represents positive direction and A1 represents negative direction. That means here both magnitude and directions are continuously changing. This is said to be alternating. Generally, this is depending upon what is this the nature of the source. These steady currents where we are observing means generally in DC source. In DC source we are observing steady, and varying currents where we are observing means generally if any electrolyte liquid is there. Initially electrolyte liquid has more amount of charges, after the provision of charges gradually decreasing. That's why varying current we may observe. Similarly, the alternating current which is frequently used by AC source in our homes, there is alternating current. The next one, here by depending upon nature of the charge, the electric currents are classified into two types by depending upon nature of the charge. Already know the charges are two types. One is said to be positive charge and another one is said to be negative charge. If the flow of positive charge is clear, that current is said to be conventional current. That is said to be, what is this one? Conventional current. Conventional current means what? The flow of charge due to positive charges. This is said to be conventional current. Always this conventional current, flow of positive charge means what? Always it is flowing from higher potential to lower potential. When the current is from higher potential to lower potential, that current is to be conventional current. Generally for electric circuits we are using the arrow mark to represent the conventional only. The another current is to be electronic current. The another current is said to be, what is that one? Electronic current. Electronic current means what? Name only electrons are there. That means what? If what is that one? Current due to the negative charge, that means electrons, then we are able to say that is said to be electronic current. This electronic current always flows from lower potential to higher potential. We are from lower potential to higher potential. Generally, if you see inside of a cell, we are able to observe electronic current. Outside of the cell, we are able to see conventional current. Yes, we are able to represent these types of currents. The next one, another one, what we require what is about the unit of current. Generally, the current SI unit, we are using SI units in what is that one? Our PU. So, the SI unit of electric current is said to be ampere. Is said to be what? Ampere, which is denoted by capital A. Here already we know current I is equal to Q by T. So here we may write ampere is equal Coulomb per Ampere is equal to 1 coulomb per second. That means what? In any one conductor in 1 second, if 1 coulomb of charge is able to move, is able to cross a particular line, then we may say that the electric current value at that particular point is said to be ampere, which is denoted by A. This one we should remember. Another one already we know, the electric current is the fundamental quantity for the system of international. The electric current is a fundamental quantity. After knowing about all these, then first of all we should know about what the origin of this electric current. That means in different objects how those electric currents are produced. That means those are produced by whom? Those are said to be charge carriers. Those are said to be what is called charge carriers. Here the electric charge carriers are different in different types of materials. Generally, frequently we are able to observe 3 types of materials. One is said to be solids, and another one is to be liquids, and another is said to be gases. Here the substances are classified into 3: solids, liquids and gases. Generally in solids, if you see metals, that means which are able to allow the flow of charges. In metals, the charge carriers are said to be free electrons. Free electrons are said to be charge carriers. Charge carriers are free electrons. In solids, these free electrons are available approximately 10 to the power of 28 per meter cube. That means the electron density, we may assume that is 10 to the power of 28 per meter cube. Suppose liquids are considered. In that liquid already we know, and the liquid, if you provide the sufficient energy for liquid, this liquid is having both ions, positive ion and negative ion. That's why here the charge carriers are said to be positive ions and negative ions for liquids. Similarly, gases. Generally, we should remember that gas is insulator. Generally, what we should remember? Gas is insulator. But here, if the gas is considered a very low pressure, gas is considered very low pressure, and if you apply high potential difference across ends of the gas container, then this gas allows the flow of charge. So here the charge carriers are said to be free electrons and positive ions. Here in the case of gases, the charge carriers are free electrons and positive ions if and only if the gas is made at low and high potential difference. Otherwise, gas behaves as insulate. This is about the electric charge carriers. After knowing about the electric charge carriers, then we should know about what is that one? The motion of free electrons. The motion of free electrons in a conductor or in a metallic conductor. Next, we should know about the motion of the free electrons in a metallic conductor. Here, so let us assume that this is the cross section of the conductor. This is cross section of a conductor. In this conductor, already we know the free electron density is 10 to the power of 28 per meter cube. That means what? So many free electrons are available. Here, initially, these free electrons are considered, these free electrons are moving. The free electrons are moving randomly in all directions. These free electrons are moving randomly in all directions. These electrons are moving randomly in all directions, and these are moving with the maximum speed. That means approximately the velocity of these electrons is 10 to the power of 5 meter per second. 10 to the meter per second means what? Very, very huge velocity. So with that much of huge velocity, these electrons are randomly moving. When these electrons are randomly moving, automatically these are experienced collisions. That means what? One electron is collide with another electron, like that collisions are appeared. So if collisions are there, then automatically due to each and every collision, the electron lost its corresponding velocity. So the resultant current we may treat as zero. We may treat as zero. Even though in a metallic conductor, the more number of electrons are available, then also the electric current is zero. Why? Because these electrons are moving with high velocity but randomly in all directions. So these electrons are colliding with each other. So resultantly, the velocity is considered, net velocity will become zero. That's why we are able to set that electric current is zero. So if this conductor is provided by a battery at both ends, if this metallic conductor is provided by a battery at both ends. Suppose if this is considered positive terminal of the battery and this is considered negative terminal of the battery, then automatically at this end the positive potential will come and at this end negative potential will come. So at one end positive potential is there and at another end negative potential is there. That's why a strong electric field is set up into the metallic conductor. If the strong electric field is set up into the metallic conductor, already we know these electrons are negative charge carriers. So all the electrons are going to move from lower potential to higher potential. That means negative potential to positive potential. So these electrons, by depending upon their corresponding orientation, these electrons move in any direction, but finally they move. Resultantly, they should move from negative potential to positive potential. Here, if their corresponding velocities all are considered, are moving with certain resultant velocity approximately, which is 10 to the power of minus 5 meter per second. Before connecting the battery, here their individual velocities are 10 to the power of 5 plus 5 meter per second in all directions. But now, after collecting the electric field, then the velocity will become 10 to the power of minus 5 meter per second. That means with small velocity, but this velocity is averagely resultant velocity is this one, which is said to be drift velocity. Which is said to be what? Now a new term came to you, is said to be drift velocity, which is denoted by Vd. So what is meant by this drift velocity? Drift velocity, which is denoted by Vd. Drift velocity means what? If any external electric field is provided to the metallic conductor, then the average velocity of the electrons in a metallic conductor is said to be drift velocity. Is said to be what? Drift velocity. Here, another one you should remember another term that is said to be relaxation time. That is said to be relaxation time, which is denoted by tau. Which is denoted by tau. Here, relaxation time means what? Already we know when the electrons are moving in a metallic conductor, the electron density is huge. Electron density is huge means what? Here, the electrons are collide with each other. If the electrons are collide with each other, then the time interval between two successive collisions of the electrons is said to be, what is that one? Relaxation time. Relaxation time means the time interval in between two successive collisions of the electrons is said to be relaxation time. So this relaxation time value is completely depends upon the number of the material. That means what? In different materials, different number of atoms with different size, those are available. So automatically the relaxation time is also able to change. So here the drift velocity is also depending upon relaxation time. How means what? Suppose let us assume that initially the electrons are at rest. That means what? Electrons are at rest. and rest initially. So their corresponding initial velocity is treated as what? 0. Is treated as what? 0. So electrons are initially at rest means what is meaning? It means before applying the electric field. Before applying the electric field, already we know the net velocity of all electrons is what? 0. So that is that one. Next, here the acceleration is considered. According to Newton's second law of motion, F is equal to ma. So A is equal to what? F divided by m. A is equal to what? F divided by m. Here, what is the force? Suppose E is the, what is that one? It's corresponding electric field. Then the force acting on the electron we may write minus small e capital E. Why? F is equal to Q into E. Charge of the electron is minus E and electric field is capital E. Divided by m. This is the acceleration, and after time, relaxation time. That is what? After relaxation time, we may write T is equal to capital tau. That means T equal tau. Now, if you want to find out its velocity according to the second equation of motion, according to second equation of motion. What is the second equation of motion? V is equal U plus AT. V is equal to what? U plus AT. So here after relaxation time, the electrons are moving with drift speed. So we may write instead of V that is equal to U0 plus acceleration minus small e capital E by m into the relaxation time is tau. So on this, the drift velocity, we may write Vd is equal minus small e capital E m into tau. This the expression for drift velocity in terms of what is the term? Electric field and tau, relaxation time. So the drift velocity value is constant or changing. That is depending upon both electric field and relaxation time. That means if the material changes, tau changes, so there is scope for changing of drift velocity. Similarly, if the battery changes, the electric field also changes, so there is scope for changing drift velocity. Its magnitude means we should ignore the negative sign. So simply you may write small e capital E by m into tau. This is that one about the relation between the drift velocity and the electric field. So after knowing about the drift velocity, then we should know another important thing here, that is the relation between electric current and drift velocity. Relation between electric current and drift velocity. Here this is very important relation in further topics also. So what is the relation between electric current and drift velocity? Suppose let us assume that this is a metallic conductor. Here the metallic conductor cross-sectional area I am considering A. And here the electron density is considered as small n. Electron density means what? Already we know in metals the electron density is 10 to the power of 28 per meter cube. That means the number of electrons available per unit volume, that is n. Now let us assume that L is the length of this conductor. L is length of this conductor. If conductor both ends are connected to a battery, then here if this is positive, then we know this is the direction of the electric field and that electric field direction is E bar. So here if it is having positive potential and here it is having negative potential, the electrons are moving from negative potential to positive potential with a drift speed Vd. With the drift speed Vd. Now here I want to establish the relation between electric current and what is that one? Electric current and drift speed. So already we know about the electric current. Electric current means what? The rate of flow of electric charge is said to be electric current. The rate of flow of electric charge is said to be electric. So here I is equal to what you write? Q divided by T. I is equal to what you know? Q divided by T. Here I want to find out charge. So suppose if what is this one? N is considered as the electron density. N is considered as electron density. Electron density means what? That is representing the number of what is that one? Electrons. So we may write Q means N into E. That will become the total charge. Each electron charge is small e and number of electrons per unit volume is N means Ne. Now we are getting per how much? Charge per how much? Unit volume. So into, if you multiply with volume, volume means what? Area into length. So here what is the area? A into length. Length means what? Speed into time. So speed what? Vd into time what? T divided by T. Carefully observe here. Here Q means what? Total charge. If N is charge, that means the electron density, then E is charge of each electron. Then the charge unit density becomes what? N into E. Into E. Into, here we are calculating per unit volume. Per total volume means what? Area into length. So area means A. Length means what? It's speed into time. Speed is Vd into time is T. So now if Tt cancel, then we may write I is equal NEA Vd. This is the relation between electric current and drift velocity. Electric current and drift velocity. That is I is equal NEA Vd. Already we know the drift velocity is equal to what we find? Small e capital E by m into tau. The magnitude of drift velocity now. So earlier already we find Vd is equal to small e capital E by m into tau. So substitute Vd here, then we will get I is equal NEA into small e capital E by m into tau. So we may write I is equal, what is the resultant? N small e square, N small e square, what is it called? A capital E divided by m into tau. This is also the expression for electric current. There is also expression for electric current. So by using this we are able to say that electric current depends upon how many factors. One is the electron density, and at the same time that depends upon relaxation time. That means electron density and relaxation time, these two are depending upon nature of the material, and N that is depending upon area of cross section. That means if the area of cross section is increased, automatically I value also increase, and at the same time it depends upon electric field. That means I directly proportional to E. This is also the expression for current value. From this we are able to estimate. We are able to estimate the what is that one error quantity, which is said to be that one current density, which is to be current density. Generally, the current density is denoted by J. The current density is denoted by what is that one? J. The current density is denoted by J. Here already we know if any one conductor, metallic conductor is considered, the current is passing through cross-sectional area. Passing through cross-sectional area. That's why the current density may be defined as the electric current per unit area. The electric current per unit area is said to be current density. Now this may be written as j is equal, try to tell in another way, j is equal to I by a. If a brings here, what the remaining n is square capital E by m into tau. This is also the expression for current density in terms of electric field. That is j is equal n here E by m into tau. So this is about current density. If the current density is considered, this is what is the term is SI unit. It may be considered as I mean electric current ampere and per unit area means meter square. So its corresponding SI unit you may write ampere per meter square. That is about current density. Here what you should remember, electric current is a scalar quantity, but current density is a vector quantity. What is the current density? Current density is vector quantity. Why current density is vector quantity? Because here the current density that there is what is calculated per current per unit area of section. That means what? The area of cross section orientation changes, then current density value also changes. So it is by J bar is equal I by A into A cap. Here J bar notation we may write I by A into A cap. This A cap represents its corresponding area vector. That means what? Here suppose the area is regarding a plane, then this A cap represents a unit vector in the direction of xy plane. Like that we are able to write the current density. Here after about the current density, then you should know another small quantity here which is said to be mobility. Which is said to be what? Mobility. When we are studying about the conductor, the mobility is also very important. The mobility is given by mu. What is meant by mobility? The mobility is the drift velocity of the electron per unit electric field. The drift velocity of the electron per unit electric field is said to be mobility. Already we know VD value. So mu is equal, what is the VD value? Small e capital E by m into tau. If E comes to here, we write this is E tau by m. Here mobility is a unit, we may write what is that one? E tau divided by m. Here small e m value constants, charge of the electron and the electron. So mobility directly proportional to relation time. That means what? If the electron collision frequently occur, then the mu value will become less, mobility will become less. If the collisions occur little bit by maintaining a time interval, the reaction time increases, so mu value is also increased. This is said to be mobility. It's SI units. If you see what is the SI unit, try to tell. Here small e what? Charge, coulomb, and tau means second, this is K. So is SI unit, we may write the unit for mobility is coulomb second per kg. In other words, in terms of velocity, if you see, velocity means what? Velocity means its SI units is meter per second divided by electric field. Electric field means what? E is equal to V by D. So V by D means what? Volt per meter. So we may write this is meter square second inverse volt inverse. Generally these two units we may use in terms of potential. If you want to express meter square per second per volt, if you want to express in terms of coulomb and kg, we may write coulomb second per kg. This is about what is that one? Mobility. Mobility of the what is that one? Electrons, free electrons. So this is about what is this one? The drift velocity and the depending factors of the drift velocity on different things. After this, you should know about another important thing that is said to be what is one? Ohm's law. The another one we are able to explain about Ohm's law. What is meant by Ohm's law? Ohm's law means what? Ohm's law means in any one electronic device at constant temperature. At what is that one? Constant temperature, the electric current passing through the conductor or passing through the given device is directly proportional to the potential difference across given conductor. That is said to be Ohm's law. Ohm's law means what? At constant temperature across the conductor, the electric current is directly proportional to the potential difference across both ends of the conductor. That is said to be Ohm's law. That means I proportional to V. Here from this we may write the proportional constant is considered I is equal some constant into V. From this we may write V is equal I divided by certain constant. Here if the reciprocal of the constant is considered as R, then we may write V is equal I into R. This is the expression for Ohm's law. Okay. So Ohm's law means what? At constant temperature of a given conductor, the electric current through the conductor is directly proportional to the potential difference across the both ends of the conductor. That means if the proportional replaced by certain proportional constant, then we may write V is I by constant. If the reciprocal of the constant is capital R, then V is equal to IR. Here where this R is said to be electric resistance. R is said to be, what is that word? Electric resistance. So if R is electric resistance, then I is equal to, you may write what? V divided by R. This is considered as equation 1. This is considered as equation 1. Now I want to know how this R is depends. How this R is already you know. Here suppose if you choose a conductor, a metallic conductor as we consider in our earlier example, then this one, if a metallic conductor is considered this and its area of cross section is A and its length is L, and when it is connected to a battery, then we may consider what is one here, the strong electric field is there and the electrons are moving with drift speed Vd from the lower potential to higher potential, lower potential to higher potential. Like this already we know. Here already we deduce the equation I is equal in terms of drift speed, I is equal to what? NEA into Vd. I is equal NEA into Vd. Here try to substitute the drift velocity speed. Why the drift velocity speed? What you got? Small e capital E by m into tau. Already know the drift speed Vd is equal small e capital M into tau. If you substitute those values, then we may write I is equal, what is I is equal? I is equal NEA into drift speed how much? Small e capital E by M into tau. This one we met I is equal N E square A capital E by M into tau. The electric field, already we know the electric field means what? Potential per unit length, potential per unit distance. So substitute capital E equal, what is the potential difference? V across the length L. So E is equal V by L. If you substitute that one, I is equal to, you may get NE square A by M V by L into tau. The same thing we may write, I is equal, you may write this as N E square tau divided by M into A by L into V. Shall we write like this? This is equation 2. Equation 2. Now compare equation 1 and 2. Here I same, right hand side VV same. So by using this, by comparing equations 1 and 2, by comparing equations 1 and 2, we may write y r is equal, there what is there? N e square tau divided by m into a by l. So from this we may write r is equal to what? M by n e square tau into L by. Now L by a coefficient, that coefficient is said to be resistivity. That coefficient is said to be what? Resistivity, which is given by rho is equal M by n e square tau. This is the expression for resistivity. Resistivity, rho is equal m by n e square tau. So here m means mass of the electron, n means electron density, e is charge of the electron, and tau is the relaxation time. Here there is no relation with respect to the dimensions of the conductor. That means conductor area may increase or decrease, or length may increase or decrease, rho value remains same. That means the resistivity of a material always independent of dimensions of a conductor. Dimensions of a conductor. Now, if you substitute here, this may be written as R is equal rho L by A. R is equal to rho L by A, which is the expression for electric resistance. Which is the expression for electric resistance. So R is equal to what? Rho L by A. So these are what the explanation regarding Ohm's law. That means we are able to write Ohm's law in different ways. In terms of potential and resistance, I is equal to V by R, and in terms of dimensions of conductor, I is equal n e square tau by m, A by L into V. Then we may write the resistance rho is equal m by n e square tau, and resistance R is equal L by L. Now up to the point you saw different quantities. Now what is minimum required? We should see regarding what is that one, SI units of them. The electric current SI unit already ampere, and the resistance SI unit, we may write SI unit of resistance is ohm. SI unit of resistance, that is, what is that one? Ohm. The ohm generally denoted by the Greek symbol big omega, that means capital omega. Omegas are two types, one is capital omega and another one small omega. The small omega we should use for angular speed, and capital omega we should use for ohm. This is the SI unit of resistance. After that, resistivity. Resistivity, if you see, SI unit of resistivity. Here resistivity means what? R is equal rho L by A. From this resistivity, rho is equal RA by L. Rho is equal to RA by L. From this, if you write their corresponding units, resistance means ohm, and area means meter square, by length means meter. These two cancel. So resistivity SI unit we may write, that is ohm meter. Resistivity SI unit we may write ohm meter. Ohm meter is the SI unit of resistivity. Here, after knowing about these quantities, then we should know about their reciprocals. Tomorrow we will see about the quantities which depending upon what is the resistance and resistivity. Thank you.